Hello, everyone, and welcome to day 5 of our Python series. I'm excited to share with you one of the most powerful skills in data collection, web scraping. Today, we'll explore how to extract data from websites using two essential Python libraries, Beautiful Soup and Selenium. By the end of this session, you'll have the knowledge to collect data from virtually any website for your own projects. Let's dive in. First, let's understand what web scraping actually is. Web scraping is the automated process of collecting information from websites. Think of it as teaching your computer to browse the web and gather data just like you would, but much faster and more systematically. This technique is incredibly valuable when you need data that isn't available through an API or when you want to monitor websites for changes. We'll be working with two main tools today. Beautiful Soup is perfect for parsing HTML and XML documents, especially when dealing with static web pages. Selenium, on the other hand, is your go-to solution for dynamic sites that require browser interaction like clicking buttons, filling forms, or handling JavaScript-heavy content. Let's start with Beautiful Soup, our first tool for web scraping. Beautiful Soup is a Python library designed for parsing and navigating HTML and XML documents. To get started, you'll need to install Beautiful Soup 4 along with a parser. I recommend using LXML for better performance, though Python's built-in HTML parser works fine for basic tasks. So, what exactly can Beautiful Soup do for you? Let me walk you through its core capabilities. First and foremost, Beautiful Soup can parse HTML and XML documents. It takes raw HTML or XML content and transforms it into what we call a parse tree, essentially a structured representation made of Python objects. This makes it incredibly easy to access and manipulate specific parts of any document. Once you have your parse tree, navigation becomes straightforward. You can move through the HTML structure in several ways, by tag name defined elements like div, anchor, or paragraph tags, by attributes to locate elements based on their ID, class, ref, or any other attribute, by text content to search for specific words or phrases, and using relationships to travel up to parent elements, down to children and descendants, or sideways to siblings in the tree. Beautiful Soup offers powerful search methods. The find method gets you the first match, while find all returns all matches. You can combine these with various filters including tag names, attributes, CSS selectors, regular expressions, or even custom functions for precise element selection. Once you've found the elements you're looking for, data extraction is simple. You can pull out text content, that's the visible text inside a tag, or attribute values like ref from anchor tags or src from image tags. One of Beautiful Soup's greatest strengths is handling malformed HTML. Real-world websites often have poorly structured or incomplete HTML, what we call tag soup. Beautiful Soup excels at making sense of messy markup and building a usable parse tree from it. Beautiful Soup also integrates beautifully with other libraries. You'll often use it with the requests library to fetch HTML content from URLs. For dynamic websites heavy on JavaScript, you might use Selenium to load the page first, then pass the rendered HTML to Beautiful Soup. And your extracted data can easily be structured in Pandas data frames for analysis or export to CSV and Excel formats. Now, let's talk about the common uses for Beautiful Soup. Web scraping is Beautiful Soup's primary purpose. You can collect product information like names, prices, and descriptions from e-commerce sites. Extract news articles, blog posts, or research papers. Gather job listings or real estate data. Even perform sentiment analysis by scraping reviews and comments. Beyond scraping, it's excellent for data mining, turning unstructured web data into organized datasets. It's also perfect for content aggregation, helping you build tools that pull content from multiple online sources into one centralized location. In essence, Beautiful Soup empowers Python developers to programmatically interact with web content, making it an essential tool
for anyone working with internet data. Let's get our hands dirty with some code. First, we need to install the required packages. Run this pip install command to get Beautiful Soup for requests and LXML. Here's a simple example of scraping a local HTML file.
Let's say you have a file called website.html. You can read it, create a Beautiful Soup object, and immediately start working with it. In this example, we're simply printing the title tag. The HTML.parser parameter tells Beautiful Soup which parser to use. Beautiful Soup makes HTML cleaning effortless. The getText method with strip equals true removes all HTML tags and extra white space, giving you clean, readable text. Finding elements is where Beautiful Soup really shines. You can search for tags, classes, IDs, and much more. The find method returns the first matching element, while find all returns a list of all matches. Notice how we use getText to extract visible text and get to retrieve attribute values like ref. Here are more specific search examples. When searching by ID, use the ID parameter. For classes, remember to use class underscore since class is a reserved word in Python. You can also find all elements with a specific class at once. For more complex selections, use CSS selectors with the select method. This gives you incredible flexibility in targeting specific elements. Understanding tree navigation is crucial for effective scraping. Every element has properties like name for the tag name, attrs for attributes as a dictionary, and direct attribute access. For text content, you have text for all text including from child elements, and string for direct text only. You can also navigate relationships using parent, children, contents, and sibling properties. A common scraping task is following links. You can extract and follow links by combining getref with the requests library. This opens up possibilities for crawling entire websites systematically. For more detailed information, I highly recommend checking out the official Beautiful Soup documentation. Now let's move on to scraping live websites. We are going to get the news titles from combinator.com. To scrape a live website, combine Beautiful Soup with the requests library. First, use requests.get to fetch the page content, then pass that content to Beautiful Soup. In this example, we're scraping Hacker News to get article titles. The problem with scraping websites is that the owners change them, which often makes your scraping script stop working. Luckily, we can use Git Copilot to help us update them quickly, like in the example that I am showing right now. The easiest way to do this is to copy an example of the HTML element that you want to scrape. It will be better just to pass that element and not the entire website, as too much context would impair the performance of the LLM. You could be using Git Copilot sidebar as usual, or you can use the inline chat to update the parts of the code that you want by typing Ctrl+I. If you do that, always remember to save by typing Ctrl+S. Before we continue, let's address an important question. Is web scraping legal? The answer depends on how you do it. You should always scrape public data only. Respect robots.txt files and website terms of service. Don't overload servers, add delays between requests when scraping many pages. And most importantly, use scraped data responsibly and ethically. Now let's explore Selenium for more complex scraping scenarios. Some websites load content dynamically with JavaScript or require user interaction, like clicking buttons or filling forms. This is where Selenium comes in. Unlike Beautiful Soup, which only parses static HTML, Selenium controls a real browser, allowing you to interact with web pages just like a human user would. Selenium can automate virtually anything a human can do on a website: filling forms, transferring information, clicking buttons, scrolling, and even playing web-based games. This makes it incredibly powerful for complex scraping tasks. That's where Selenium comes in. Selenium WebDriver is like having a robot that can control a real web browser. To start running Selenium, you will need a browser, preferably Chrome, and then run pip install Selenium. In your Python code, import WebDriver from Selenium and create a driver instance. The Chrome driver acts as a bridge between your Selenium code and the Chrome browser. Remember to use driver.quit after completing tasks to ensure a fresh browser instance for future runs. Let's look at a practical example. This code opens python.org, finds event times and names using CSS selectors, and prints them together. Notice how we use find elements, plural, to get multiple matching elements, then zip them together for processing. And this is the result when you execute the script from the terminal. Finding and selecting elements is fundamental to Selenium automation. Selenium offers various strategies to locate HTML elements. Use the find element method for single elements and find elements for multiple matches. The by class specifies location strategies like by.className, by.id, by.name, or by.linkText. After finding an element, use the text property to retrieve its content. Chrome developer tools are invaluable for inspecting HTML structure and identifying the right selectors for your elements. Each of the finding strategies works best for a specific element type. By name is useful for form input fields. By link text is useful when you want to click on links with a visible text. You can also find all elements or just the first one. For every find elements method, there is a find element counterpart. Also, a basic tool when doing web scraping is the Chrome developer told to examine the HTML, identify IDs, class names, or other attributes such this path within the HTML tree. Selenium truly shines when automating interactions. You can click elements using the click method after identifying them. For typing into input fields, use sendKeys method. For special keys like enter or return, import the keys class from selenium.webdriver.common.keys. Let's wrap up what we've learned today. Remember, use Beautiful Soup for static HTML scraping and Selenium for dynamic, interactive sites. Always respect website rules and ethics in your scraping activities. Congratulations! You now have powerful tools to collect data from virtually any website. Web scraping opens up incredible possibilities for data analysis, research, and automation. As you continue your journey, remember that practice makes perfect. Start with simple projects and gradually tackle more complex scraping challenges. The combination of Beautiful Soup and Selenium gives you the flexibility to handle almost any web scraping scenario you'll encounter. Don't forget to like, subscribe, and drop a comment with your own web scraping projects. Thank you for joining me today, and happy scraping!